My name is Jim Keegan, 4th and 5th grade teacher at Sandy Mountain Elementary School. Today what I'm going to do is I'm going to introduce you to adding fractions with unlike denominators using Cuisenaire rods. In this particular case, in previous videos that I've done, I demonstrated how to add fractions with like denominators. Now we're going to get into something a little bit more intricate and a little bit more difficult for the students. But again, what we're going to do is we're going to start off with a problem where we have 1/2 plus 1/3 is equal to n, and then work our way into the color train again. Now in this particular case, again, we're going to use orange plus red is equal to the whole. The students will create the color train, still identifying that equal parts have to make the whole. That defines the fraction that we're using. Now when we come back to the equation that we have, I again have the students figure out if I have 1/2 plus 1/3, what color rods will we use in order to represent 1/2? The students look over at the color train and they identify that as the dark green rod. Then I have them go over, and now instead of the ease of having the same colors, they have to identify what color rod is equal to 1/3. In this particular case, it would be the purple rod. So the students would have to take the purple rod out. Now in the previous videos, what I had the students do was to put the rods together, and I would have them do the same thing. Now with adding fractions with like denominators, the students were able to make the conjectures that you have different or the same colored rods, so you would have the same answers. So 1/4 plus 1/4 would equal 2/4. But in the previous ones, I always had the students find the one color rod that was equivalent to the two sections. And in this particular case, it's the orange rod. Now the reason for this is, again, n is equivalent to one number. It's equal to this fractional number. But in order to use this rod correctly, now here's the hard part. Many students, when they see 1/3 plus or 1/2 plus 1/3, they usually say 2/5. They add the numerators, and then they're not too sure what to do with the denominators, so they add them anyway. Even though they know with like denominators, they're not supposed to add the denominators together. This orange rod now defines what 1/2 plus 1/3 is equivalent to. So we come back over to the color train. Now their conjecture of 2/5 makes sense numerically, but now all of a sudden when they get into the color train, they're starting to notice, and again I have them compare the orange rod to the whole. It's not equivalent to the whole, so now we work our way down on the color train. Is equivalent to halves? And in this case, no, it is not equivalent to halves. Is it equivalent to thirds? No, it is not. We continuously work our way down using the fourths? No. Using the sixths. Now in this particular case, the students are able to identify that 1/2 plus 1/3 is equivalent to 5 of the 6, making it 5/6. So now they've realized that 1/2 plus 1/3 is equal to 5/6. They can go down again into the 12ths and find there is an equivalent form of that, which is equal to 10/12. So they find that the answer for 1/2 plus 1/3 is equal to the orange rod, which now I've identified and defined this as 5/6 and 10/12. Both of those answers are correct. If they put that down for n, that would be perfectly justifiable. The students then are able to justify their answers, identifying that 1/2 plus 1/3 is equal to the orange, and going back to the color train and proving that the length of the orange is equivalent to 5/6 or 10/12. That's adding fractions with unlike denominators using Cuisenaire rods.